Okay, I guess we're going. Let's take a look at number 4 from the 2024 AP Stat exam. We'll make an attempt, and then when the reading's over and we get the scoring rubrics, we'll see how we did. I've looked at the stem, but I haven't read through the problem to see what's going on, so we're going to go at it pretty cold. Online game, players move through a virtual world collecting geodes, a type of hollow rock. When broken open, the geodes contain crystals of different colors that are useful in the game. Red crystal is the most useful crystal in the game. Color of the crystal on each geode is independent. And probability that a geode contains a red crystal is 0.08. Sarah, a player, will collect and open geodes until a red crystal is found. Calculate the mean of the distribution of the number of geodes Sarah will open until a red crystal is found. Let's see, after they released these, I asked my students, and one of them told me that everything was on the formula sheet that you needed. And they appreciated that. So, this is a geometric distribution if we're going to calculate how many we will open until we have a success. And so the mean of a geometric variable x is a geometric random variable. That counts the number of trials to the first success. The number of trials, number of geodes open, we have to open to get first red. And so the mean of a geometric distribution is given on our formula, and it's 1 over probability. Sorry. Thank you. Okay. Thank you, ma'am. I appreciate it. So the mean of x, expected value of x, is 1 over p. In this case, p is 1, or p is 0.08. So 12.5 is the expected value of x. Calculate standard deviation of the distribution of the number of geodes Sarah will open until a red crystal is found. Show your work. There again, we have the standard deviation of a geometric random variable x. So standard deviation of x is the square root of 1 minus 0.08 over 0.08. So that's square root of 0.92 over 0.08. Again, we use the calculator. Square root 0.92 out there divided by 0.08. And we got 11.99. How about that? This is going to be, I'm going to go ahead and put the context here. I think we've got it, but 12.5 geodes and 11.99 geodes. It's pretty easy, right on the formula sheet. Another player, Conrad, decides to play the game, will stop opening geodes after finding a red crystal or when 4 geodes have been opened, whichever comes first. Let y equal the number of geodes Conrad will open. The table shows a partially completed probability distribution for the random variable y. So the first geode to be read was 0.08. The second geode to be read would be open 1 that's not read times 0.08. And that would give us, we're going to double check, but this is what it's going to be, 0.92 times 0.08, and that's where they got the 0.0736. And so to get the third, we would get 2 non-red, then 1 red, 0.08. So we're going to do 0.92 times 0.92. That's going to be 0.067712. And now to get the fourth, since he's going to stop no matter what, red or nothing, we're going to add all those up and subtract them from 1. This is 1 minus the probability that x is less than or equal to 3. So we're going to do 0.08 plus 0.0736 plus 0.067712, and we're going to subtract that from 1 and get 0.778688, just to make sure I did everything right. I'm pretty sure I did, but I'm going to add all that together to make sure it adds 1. Make sure I didn't make any simple mistakes. It does. So that is our probability distribution. Oh, we did this all for part I. We showed probability that y is equal to 3. Oops. Is 0.92. Oops, sorry. Times 0.92 times 0.08. It's the probability that we open, and they said we're independent up here in the stem of the problem. So 0.92 times 0.92 represent the first two geodes we open that aren't red, and the third one that we open is red, is 0.08. And they said that we said it equals 0.067712, and we did the probability that y equals 4 is 1 minus the probability that y is less than or equal to 3, which we said was 1 minus and then 0.08 plus 0.0736 plus 0.067712. Consider the table in your results from Part B. Calculate the mean of the distribution of the number of geodes Conrad will open. Show your work. Okay, this is different. This is not the strict geometric distribution anymore, so now we have to go to the mean of a random variable. The mean of y, or the expected value of y, is the sum of the probabilities times y. So we have 1 times 0.08 plus 2 times 0.0736 plus 3 times 0.067712 plus 4 times 0.778688. And we'll go ahead and type that in the calculator. 0.08 plus 2 times 0.0736 plus 3 times 0.067712 plus 4 times 0.778688. We get 3.545. Interpret the mean of the distribution of the geodes Conrad will open, which was calculated in Part CI. So this means if Conrad played the game many times, say many, many times, a lot of times, long run average, he can expect the average number of geodes, average he opens to be about 3.545 for each game, per game. Let's say per game. That's number 4. That's not too bad for a probability problem. Maybe one of the easier ones I've seen.